Good day to all of you. We are the grade 12 STEM students of Holy Cross High School. That will help you understand the chapter 2 of chemistry with the topic atoms, ions, and the periodic table. So, let's begin. The following are the learning objectives. Explain what is Dalton's atomic theory, identify the structure of the atom, discuss about ions, discuss about atomic mass, and explain the periodic table of elements. So, who is John Dalton? John Dalton was an English chemist, physicist, and a meteorologist who lived from September 6, 1766 to July 27, 1844. He is most known for introducing the atomic theory into chemistry and for his color blindness study, which is frequently referred to as Daltonism after him. So here we are with Dalton's atomic theory. Following are the key points of Dalton's atomic hypothesis as it evolved. First, atoms are incredibly microscopic particles that make up elements. Their size, mass, and other properties of atoms of the same element are all equal. The size, mass, and other qualities of atoms of other elements may differ. Second, subdivision, creation, and destruction of atoms are all impossible. Chemical compounds are formed when atoms of different elements mix in simple whole number ratios. Third, atoms are joined, separated, or rearranged in chemical processes. So, according to Dalton's atomic theory, all matter is made up of atoms, which are indivisible and indestructible. Dalton's atomic theory also maintained that all compounds were made up of fixed ratios of these atoms. All atoms of a given element have the same attributes, including their weight. The mass of atoms of various elements varies. Atomic particles. These are small particles found inside an atom. There are more than 40 known subatomic particles, but only 3 have importance in chemical behavior. And these 3 are proton, electron, and neutron. Protons are particles that are positively charged and are also located in the nucleus. Protons, including neutrons, give the atom mass but are not involved in any chemical reactions. The number of protons that an atom has is called the atomic number, and it determines the identity of the atom. Electrons are particles that are negatively charged and found in shells that surround the nucleus. They essentially have no mass, but in chemical reactions, they play an important role. The first shell of electrons could accommodate 2 electrons. Additional shells of electrons will contain up to 8 electrons for most of the time. Neutrons are no charged particles contained in the core of the atom. They give atoms mass but are not involved in any chemical reactions. J. Thomson proved the existence of electron, a negatively charged subatomic particle, in 1897. He experimented with cathode ray tubes in a series of experiments. Cathode ray tubes, or CRTs, are fundamental components of older television picture tubes and computer monitors. The screen contains chemical compounds that glow when struck by fast-moving electrons. You might wonder on how protons and electrons are arranged inside an atom. Thomson's plum pudding model of atomic structure claimed that protons and electrons are evenly distributed throughout the atom. As you can see in the picture, electrons in the atom are embedded in a sphere of positive charge like raisins in plum pudding. In the picture shown, the nuclear model of the atom, protons, red spheres, and the neutrons in yellow spheres are located in a tiny nucleus at the center of the atom. The space outside the nucleus is occupied by the electrons. The nuclear model of the atom, developed in 1907, was based on Rutherford's experiment. According to the model, the nucleus houses the protons as well as the majority of the atom. in what is known as an electron cloud. Electrons exist outside the nucleus. After discussing about nuclear atoms, here we are with isotopes. An isotope of an element is an atom that contains a specific number of neutrons. Most of these elements are constituted by more than one isotope with different numbers of neutrons. For instance, most hydrogen atoms have no neutrons, and their nucleus consists of only a single proton. However, hydrogen atoms may be subjected to variations, such as those that have one or two neutrons. Isotopes are alternative versions of certain elements comprised of a different atomic mass but still has the same atomic number. An element's atomic number is simply the number of protons that are within the atom. Isotopes of the same element may have different quantities of neutrons, though the proton count remains the same. There are two main types of isotopes: radioactive isotopes and stable isotopes. Stable isotopes have a stable proton to neutron combination and do not display signs of decay. This stability is derived from the amount of neutrons currently present in an atom. An unstable atom with too many or too few neutrons will be rendered unstable and thus disintegrate. However, as stable isotopes do not decay, they do not pose any serious radiation-related health risk. Radioactive isotopes, on the other hand, are comprised of unstable combinations of protons and neutrons. These decaying isotopes emit radiation, which include alpha, beta, and gamma rays. This illustration shows the subatomic particles in the nuclei of hydrogen isotopes. The mass number and atomic number of an isotope are often represented by the notation called an isotope symbol, as shown in the figure below. Mass number equals number of protons plus the number of neutrons. This is one way to distinguish between isotopes by their mass number. The mass number is represented as A of an isotope, the sum of the number of protons, which is letter Z, and the number of neutrons N in its nucleus. So let's move on to the topic atomic mass. Atomic mass is the quantity of matter contained in an atom of an element. Mass of a single hydrogen 1 atom is 1.67380 times 10 to the power of negative 24 grams. The mass of a carbon 12 atom is 1.99272 times 10 to the power of negative 23 grams. Numbers small as these are difficult to use and remember. Because of that, scientists came up with a new method to express masses of atoms in a more convenient way, and it is called the atomic mass unit, or AMU. This mass scale uses the most abundant isotope of carbon, which is carbon 12. It is the standard to which all the other atoms are compared. Carbon 12 is assigned an atomic mass of exactly 12 atomic mass units. Always keep in mind that one atomic mass unit is equal to 112 times mass of one carbon-12 atom. That will eventually equal to 1.6606 times 10 to the power of 24 grams. Aside from atomic mass unit, there is also a modern technique called mass spectrometry. Using this, we will be able to find the mass of each isotope and measure how much of each is present in a sample. A mass spectrometer measures masses of individual atoms. Electrons are removed from atoms or molecules to produce ions that are accelerated through a magnetic field. Mass spectrometry is also used in order to determine the relative amounts of different isotopes in a sample of an element. Mass spectrometry is an analytical tool used for measuring the mass-to-charge ratio of one or more molecules present in a sample. These measurements can often be used to calculate the exact molecular weight of the sample components as well. So let's move on to ions. How are ions different from neutral atoms? The number of electrons in a neutral or uncharged atom equals the number of protons. Hence, the overall charge on the atom is zero. This is due to the fact that the positive charge on each proton is equal in magnitude but opposite in sign. What happens if the number of protons and electrons in a molecule isn't equal? The entire charge isn't zero in such case. If the atom has more electrons than protons, the total charge is positive. If there are more electrons than protons, then it is negative. The two types of ions, cation and an anion. A cation is a positively charged ion that contains fewer electrons than the number of protons in the nucleus. Meanwhile, an anion is a negatively charged ion that contains more electrons than the number of protons in the nucleus. So here we are with our last topic, the periodic table of elements. The periodic table of elements is a complete list of all known elements currently present on Earth, according to the International Union of Pure and Applied Chemistry. The periodic table is organized so that scientists can quickly discern the properties of individual elements, such as their mass, electron number, electron configuration, and their unique chemical properties. This image is an example of a periodic table wherein you can classify the metals, nonmetals, and metalloids. Example of classification of elements. Classify each of the following elements by group number, group name, period, and as metal, nonmetal, or metalloid. So for the first given, sodium, second, silicon, third, bromine, and lastly, copper. So the answers are sodium is in the alkali metal group, period 3, and it is a metal. Silicon is in period 3, and it is a metalloid. Bromine is in the halogen group, period 4, and it is a non-metal. And lastly, copper is in the transition metal group, period 4, and it is a metal. You can use your periodic table in order to identify the different classifications of elements. So that's all for the whole chapter 2 of chemistry, and I hope you learned something from our video.